Okay, so 4B is great. 4A we'll use again. So what I want to do now is I want to take equations, well, equations 1 and 2, and I want to get rid of this average velocity here. In order for me to do that, I'll just set equation 1, the right side of equation 1, onto the left side of equation 2. Alrighty. So this is going to be SF minus S initial over time equals to VT initial plus VT final all over 2. We're going to call this equation number, well, before we even call it something, let's just go ahead and represent it in terms of SF by itself. So that's going to be VT initial plus VT final over 2, all of this times the time. So if we wanted to find the displacement, we can find the displacement using this particular equation. We would just need to know the initial velocity, the final velocity, and the time of flight, or the time it took for the event to take place. Okay. Another thing that we can do is we can actually take equation number 4. We could substitute in for VTF. We'll place it right here. See that? I'm going to place it right there. So let's go ahead and do that. It's going to end up being VT initial plus VT initial plus AT. And this is still like tangential, times T all over 2. And then this is going to equal to 2 VT initial. How can my hand be recognized? Plus AT all over 2 times T. So now we're going to end up with 2 VT initial over 2 plus AT times T all over 2 times T. So we see 2 over 2 is just defined as 1. So we end up with VT initial plus 1/2 AT T squared. Let me go ahead and multiply through by the T as well. All right. So we come up with a final equation that looks like this. SF minus S initial equals to VT initial times the time plus 1/2 times the acceleration, average acceleration times time squared. We are going to call this one, so that's 4. This should be 5. Let's call this equation number 6. So that's the equation, these last two equations, equation number 5 and equation number 6. These are the two that we'll be able to use in the following